Hello everyone! Welcome to a truly amazing journey into the world of machine learning. Think of it as teaching a computer to learn, just like you learn to ride a bicycle. At first you might have wobbled and fallen, but with practice you got better. You learned from your experiences. Machine learning is all about teaching computers to learn from experience, which we call data. We are going to explore how we can give computers this incredible power. It's not magic, it's science. And you can be a part of it. Get ready to have your mind blown by what you can create. This adventure will empower you to build things that can think, predict, and help us solve some of the world's biggest problems. This field might sound super complicated, like something only geniuses in white lab coats can do, but I'm here to tell you that's not true at all. You can start learning right now, today. We're going to break it all down into small, easy-to-understand pieces. Imagine building with Lego blocks. We'll start with the simplest block and then add more until we have something amazing. We will look at how machines can recognize pictures, understand our words, and even help doctors find diseases. The goal is to make these powerful ideas accessible to everyone, because when more people understand science and technology, we can all work together to build a better future for our planet and everyone on it. Machine learning is a part of a bigger field called artificial intelligence, or AI. You've probably heard a lot about AI lately. It's the idea of making machines that can think and reason like humans. Machine learning is the most practical and powerful way we are making AI happen right now. It is the engine that drives so many things we use every day. From the app that suggests your next favorite song to the way your email filters out junk mail, machine learning is working quietly in the background. It's not about creating scary robots from the movies. It's about creating smart tools that can help us in our daily lives, making them easier, safer, and more fun. So put on your thinking caps and get ready for an incredible ride. We are going to demystify the buzzwords and show you the real science behind them. By the end of this, you won't just understand what machine learning is. You'll have a roadmap to build your very own project. You will see that with a little bit of curiosity and a willingness to try, you can teach a machine to do incredible things. The future is being built with code and data, and this is your invitation to become an architect of that future. Let's get started on this wonderful journey of discovery and creation. Consider the following. You are about to become a creator of intelligence. So, what exactly is machine learning? Let's use a simple example. Imagine you want to teach a computer to tell the difference between a picture of a cat and a picture of a dog. You wouldn't write a long list of rules like if it has pointy ears and whiskers, it might be a cat. That would be impossible. Instead, you would show the computer thousands of pictures of cats and thousands of pictures of dogs. You would label each one, this is a cat, this is a dog. The computer, through a special program called an algorithm, starts to find patterns on its own. It learns the features that make a cat and a dog a dog. That's learning from examples or data. This process is so important because it allows us to solve problems that are too complex for humans to program directly. Think about recommending a movie. Your favorite streaming service doesn't have a person watching every movie and writing rules. Instead, its machine learning system looks at what you've watched before. It also looks at what millions of other people with similar tastes have watched. It finds patterns in all that data and makes an educated guess about what you might like next. This is why machine learning is transforming every industry, from entertainment and shopping to healthcare and transportation. It helps us find valuable insights hidden in massive amounts of information. The real-life uses of this technology are all around you, every single day. When you talk to a virtual assistant on your phone, like Siri or Alexa, that's machine learning understanding your speech. When you use a map app to find the fastest route, it's using machine learning to predict traffic. Even the spam filter in your email inbox is a machine learning model that has learned to spot the difference between important messages and junk. These systems are constantly learning and getting better over time. The more data they see, the smarter they become, making our interactions with technology more natural and helpful. It's a quiet revolution happening right in our pockets and on our screens. This ability for a system to improve itself without being explicitly reprogrammed is the core idea. Arthur Samuel, a pioneer in this field, defined it beautifully back in the 1950s. He said it's the field of study that gives computers the ability to learn without being explicitly programmed. This is a powerful concept. It means we can build systems that adapt to new information and changing environments. We can create medical tools that get better at detecting diseases as they analyze more patient scans. We can build financial models that learn to spot fraud more effectively. The possibilities are truly endless, and it all starts with the simple idea of learning from data. Now, you might be thinking, do I need to be a math genius to do this? The answer is no. While advanced machine learning involves deep mathematics, you only need to understand a few basic concepts to get started. Think of it like cooking. You don't need to be a world-class chef to make a delicious meal. You just need to know how to follow a recipe. The first ingredient is a little bit of linear algebra, which is just a fancy way of talking about data organized in tables like a spreadsheet. We call these tables vectors and matrices. It helps us work with lots of data points all at once, which is super efficient for our computer. The second key ingredient is probability. This helps us understand uncertainty and make predictions. For example, if we want to predict if it will rain tomorrow, we can look at data about today's weather, like humidity and temperature, and use probability to say there is an 80% chance of rain. It's all about making the best guess based on the evidence we have. The third ingredient is a tiny pinch of calculus, specifically the idea of a gradient. Imagine you are on a hill and want to get to the bottom as fast as possible. The gradient tells you which direction is the steepest way down. In machine learning, we use this idea to help our model go down the hill to find the best possible answers and minimize its mistakes. To put all this math into practice, we need some tools. The best language to start with is Python. Why Python? Because it's known for having a simple, readable syntax that looks a lot like plain English. This means you can focus more on learning the machine learning concepts and less on complicated programming rules. More importantly, Python has an amazing community that has built powerful libraries which are like pre-made toolkits. These libraries handle all the heavy math for you so you don't have to build everything from scratch. It's like having a set of power tools instead of just a hammer and nails. One of the most essential tools in your Python toolkit will be the Jupyter Notebook. Imagine a notebook where you can write code, run it, see the output, and write notes all in the same place. That's a Jupyter Notebook. It's an interactive environment that lets you experiment with your ideas piece by piece. You can write a small chunk of code to load your data, run it, and see if it works. Then you can write another chunk to visualize it, and so on. This makes it incredibly easy to explore your data and test your models step by step. It's the perfect laboratory for a budding machine learning scientist like you. Machine learning isn't just one single thing. It comes in a few different flavors, just like ice cream. The three main types are supervised, unsupervised, and reinforcement learning. The most common type is supervised learning. This is what we talked about with the cat and dog pictures. The supervisor is you. You provide the computer with data that is already labeled with the correct answers. You show it pictures labeled cat and dog, or you give it house prices based on features like size and location. The goal is for the model to learn the relationship between the features and the labels, so it can make predictions on new, unlabeled data. It's used for tasks like prediction and classification. Next up, we have unsupervised learning. In this case, there is no supervisor. You give the computer a bunch of data without any labels and ask it to find interesting patterns or structures on its own. Imagine giving it a huge box of mixed fruits and asking it to sort them into groups. It might group them by color, size, or shape. It doesn't know what a banana or apple is, but it can figure out that certain items are similar to each other. This is incredibly useful for tasks like customer segmentation, where a company wants to find different groups of customers with similar behaviors, or for finding anomalies, like an unusual transaction on a credit card. The third flavor is reinforcement learning, and this one is all about learning through trial and error, like training a pet. You put an agent, your model, in an environment like a video game or a maze. The agent can take certain actions. For every action it takes, it gets a reward or a penalty. The goal of the agent is to figure out the best sequence of actions to take in order to maximize its total reward over time. This is the technology behind computers that can play complex games like chess or Go at a world champion level. It's also used to teach robots how to walk or to optimize the operations of a factory. Knowing which type of learning to use depends entirely on your problem and your data. If you have a clear goal and labeled data, like predicting house prices, supervised learning is your best bet. If you want to explore your data to find hidden groups or patterns, like discovering customer segments, you'll want to use unsupervised learning. And if you're trying to train a system to make a sequence of decisions in a dynamic environment to achieve a goal, like a self-driving car learning to navigate, reinforcement learning is the way to go. Each flavor has its own unique strengths and opens up a different set of amazing possibilities. Every great machine learning project starts with one crucial ingredient: data. But data in the real world is often messy, incomplete, and full of errors. Think of it like trying to cook with ingredients that are dirty and all mixed up. You can't just throw them in the pot. The first step is always data collection. This could mean downloading a public dataset from a website like Kaggle, scraping information from the web, or using data from your own company. The quality and quantity of your data will have the biggest impact on how well your model performs. Good data is the foundation of a good model. Once you have your data, the next critical step is data cleaning and preparation. This is often the most time-consuming part of a project, but it is absolutely essential. This involves tasks like handling missing values. For example, if a house's age is missing, you might fill it in with the average age of all other houses. You also need to correct errors, like a house price being listed as 0, and remove any duplicate entries. This cleaning process ensures that your model is learning from accurate and reliable information. It's like washing and chopping your vegetables before you start cooking. It prepares your ingredients for the main event. After cleaning, it's time for data exploration and feature engineering. This is where you become a data detective. You use tools to create charts and graphs to visualize your data. This helps you understand the relationships between different variables. For example, you might plot house prices against their size and see a clear trend. Bigger houses tend to be more expensive. Feature engineering is the creative process of creating new input features from your existing ones. For instance, you might combine the number of bedrooms and bathrooms into a new feature called total rooms. This can often help your model learn more effectively by giving it more meaningful signals. Finally, with your clean and well-prepared data, you are ready to choose and train your model. For a beginner project like predicting house prices, a simple model like linear regression is a great place to start. It tries to find a straight line that best fits the data points. You split your data into two parts: a training set and a testing set. You use the training set to teach the model. The model looks at the features, size, location, and the labels, prices, in the training data and adjusts its internal parameters to make the best possible predictions. This training process is where the learning actually happens, as the model figures out the patterns connecting your features to the outcomes. Once your model has been trained, how do you know if it's any good? This is where evaluation comes in. You use the testing set, the part of the data that the model has never seen before, to check its performance. You let the model make predictions on this test data and then compare its predictions to the actual correct answers. For a house price predictor, you might use a metric called mean absolute error, which tells you, on average, how far off your model's price predictions are from the real prices. This step is crucial because it gives you an honest assessment of how well your model will perform on new, real-world data. During training, you have to be careful of a common trap called overfitting. This happens when your model learns the training data too well, including all its noise and random quirks. It's like a student who memorizes the answers to a practice test but doesn't actually understand the concepts. When they see a new question, they can't answer it. An overfitted model performs great on the training data but fails miserably on the test data. To prevent this, you can use techniques like regularization, which slightly penalizes the model for being too complex, or by using more training data. The goal is to create a model that generalizes well to new, unseen situations. Now that you have a trained and tested model, why not let others use it? You can build a simple user interface, or UI, to wrap around your model. This doesn't have to be complicated. You can use a Python library like Streamlit or Flask to create a basic web page with a few input boxes. A user could enter the size of a house and the number of bedrooms, click a button, and your model would run in the background and display the predicted price. This brings your project to life and makes it accessible to people who don't know how to code. It transforms your model from a piece of code into a useful tool. The final step is to share your creation with the world. You can publish your project online so that anyone with a web browser can try it out. Services like GitHub Pages, Heroku, or Python Anywhere make it relatively easy to deploy your simple web application. It's also incredibly important to write good documentation. Explain what your project does, how you built it, and how to use it. This not only helps others understand your work but also solidifies your own understanding. Sharing your work, joining online communities like Reddit's R Machine Learning, and getting feedback is a fantastic way to learn, improve, and become part of the global machine learning community. To make your journey smoother, focus on learning the key libraries that do the heavy lifting. For data manipulation and analysis, the go-to library is Pandas. It lets you load and work with data in a table-like structure called a data frame. For numerical operations and working with those matrices we talked about, NumPy is essential. And for training most of your first models, scikit-learn is an absolute powerhouse. It has pre-built algorithms for almost any task, along with tools for splitting data and evaluating your models. Learning these 3 libraries will give you the superpowers you need to tackle a huge range of projects. As you grow, you might encounter massive datasets that don't fit on your computer, but don't worry. Tools like Apache Spark are designed to handle that big data. A fantastic way to start is by picking a beginner-friendly project. Predicting house prices is a classic for a reason. The data is easy to understand and the goal is clear. Another great project is classifying species of flowers from the famous IRIS dataset, or trying to predict passenger survival on the Titanic. These projects will walk you through the entire workflow, from loading data to evaluating your model. Don't be afraid to start small. The goal of your first project isn't to build the world's most accurate model, it's to learn the process. Each line of code you write and every bug you fix is a valuable learning experience. Celebrate your progress and enjoy the thrill of building something that works. The key to long-term success in this field is to stay motivated and be consistent. It can be challenging at times, but remember why you started. Set small, achievable goals for yourself, like this week, I will learn how to clean a dataset. Find a community of fellow learners to share your struggles and successes with. Teaching someone else what you've learned is one of the best ways to deepen your own knowledge. Don't compare your Chapter 1 to someone else's Chapter 20. Everyone starts somewhere, and every expert was once a beginner. Keep your curiosity alive, ask questions, and never stop experimenting. Your persistence will pay off in amazing ways. Finally, let's look at the exciting future. Machine learning is evolving at an incredible pace. We are seeing trends like generative AI, which can create new text, images, and even music. Think of tools like ChatGPT. Another area is explainable AI, or XAI, which focuses on making our models less of a black box so we can understand why they make the decisions they do. This is crucial for building trust in AI systems, especially in important areas like medicine. The journey of learning never ends. So I encourage you to take that first step. Start a project, share your work, and become part of this incredible revolution. Go out there, be curious, and change the world.